No. Okay, go.
I heard you're also a teacher. Can you tell us more about the classes that you have taught?
Okay, as a graduate student, I used to teach a microbiology classes and nursing student microbiology class, pharmacy microbiology class, and biochemistry lab. And there I teach the different tests done in clinical studies, set up how to identify the diseases, and then pathogenic bacteria, how to identify them for the microbiology classes. And then right now I teach a class in stem cell in biomedicine, where I teach them what's the basic of the stem cells, how it is generated in the body, and how you identify it, and how you develop a artificial stem cells, it's embryonic stem cells especially, by using the skin cells and converting into induced pluripotent stem cells. And from there we can differentiate into different cell lines. And I teach them to think out of the box and how not to fabricate data. That's all.
What is your favorite part about teaching students?
Best is to instill them the basic knowledge of the stem cells and how to overcome the problems in the research and how to maintain ethics while doing the research.
What is your most favorite part about what you do right now?
My favorite is to troubleshoot the experimental part and think out of the box and generate new ideas for the lab and to give ideas to other people.
Do you have any advice for us as undergraduate students studying biology? Do you have any advice for us as undergraduate students who are studying biology?
I didn't get it, I'm sorry.
Do you have any advice for us as students
Oh,
studying
okay.
biology?
First thing in undergraduate is make sure that you have a strong knowledge of basic knowledge. Much of the building blocks of the science is known for development, but you have to think out of the lab, out of the box, and also you will have to work hard because ideas do not work unless you do. And you have to work long hours and you have to think out of the box and to apply it into doing the research. And 60% of the research published so far is not been not able to be done again. Means it has effect or it's not reproducible. So you have to make sure you do it several times and understand it very well and always maintain data on that and all in detail. That's most important in science.
How important do you think the field of biology will be in the future?
Okay, biology field is moving very fast. The thing is, much of the research we know so far from the biology outcome is by happen chance and by accident, what we call it. And so it's moving so fast that it's a lot of new technology is developing, and with the AI, artificial intelligence, there will be more faster development in the biology, and especially the CRISPR-Cas9 system is a new development whereby they can cut and repair a genetic defect of the human diseases. And so that also was found by accident. And so it is moving very fast and you have to keep up with it. At the same time, you must have a basic knowledge. If you have a basic knowledge, you can do much faster all the research you can.
What are some of the ethical problems you see right now in biology?
Ethical research is the funding for research is very difficult. It's very competitive, and there are too many applications for the limited amount of funds. So you have to be a top of the cream, and what happens lately, because of competition, there are a lot of fake research published, even from the well-known university, and they have to retract back. Within the last 6 months, almost a very well-known university has to disband 3 top-notch investigators from doing research because they will publish the fake data. So you will have to require that ethics is very important in doing the research. And again, there is an issue with the biology in the research that there is always too much pressure, and it should not be there.
How can we recognize research that is not true to what it's saying?
Not there too. The way it has been, what happens is they publish a paper. Normally a similar, they publish a paper, so they want to become famous, and somebody wants to duplicate it, and it's not able to duplicate it, that work. And so what happens, several labs finds out that it's not reproducible, and so they send a letter to the journals where they publish it, and then ask them the explanation, and so the journals goes after the authors and ask them why it is not reproducible, and by that way they are able to catch a very well-known fake research. And so it is very common nowadays becoming, because same research is done in several labs parallel in a different aspects. So it's easy to fake it and easy to get caught because of the AI. Nowadays they have programs whereby they can put the data from published data, and it can artificial intelligence will analyze and tell us either it is a fake or it is real.
If you weren't doing research, what would you do instead?
Well, there is not financial reward in research, and so if I want, I think sometime I should have done a pharmacy or in a medical school, where there is always a job. You can always teach until the late age, and you'll be more productive.
What motivates you to keep doing research?
Well, actually it was an ego to be a scientist in the early days, and so I work on producing a new antibiotics. That was my undergraduate studies, where I discovered a new antibiotic, and I published in an international journal. And so I wanted to be famous that I can develop a new antibiotics by where it can suppress resistant diseases. So I wanted to have an ego, and I wanted to be proud of being scientist.
Thank you.
You're welcome.